If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on GATE Digital Electronics series. So today we will be solving again 5 questions starting from question number 56, 57, 58, 59 and then 60. Okay, then let's try to solve these questions. Now if you come to 56, the cascade of 3 identical modulo 5 counter. Modulo 5 counter means it has 5 states to count. Then overall modulus, it will be, if they are connecting cascaded, it is always 5 cube. I think you have studied in counter. So it is 5 cube, this 1 2. You can think it, suppose one counter is counting 2 states, 0 and 1, 2 states. So if you connect same type of 2, so next one it will also count 0 1. So for 0 it will have 2 options, 0 1 0 1. For 1 also it will have 2 options, 0. So ultimately you have 0 0 0 1 1 0 1 1. So it is 2. For each one you are getting 2. So again, for if you have another one, so for this one also you will get to this one. So you ultimately will get 2 into 2 into 2. It is always cube. So it is 125. This is the overall modulus. So this one, JK flip-flop is implemented by T flip-flops. Identified the correct implementation. So for this type of things, if you want to make one flip-flop using another flip-flop, we have already seen one. For that, what table we need to draw? We need to write excitation table. So that is very important. So for excitation table, let me write the truth table first for JK. Qn plus 1 is, if it is 0 0, then it is holding its state. If it is 0 1, it is 0. If it is 1 0, it is 1. If it is 1 1, then it is changing. So this was the for JK. T you already know. T it is 1, then it will change. If it is 0, it will hold its state. That's why I am not writing T. So what is the excitation table? We write it in this way. Qn from one state to you go, want to go another state. Using JK, how you will go, and else if you use T, how you will go. So if it is 0, you want to go to 0, 0 1 1 0. So these are the possibilities you have. We have drawn one excitation table earlier also. You can check that out also. Okay. So if it is 0 to 0, 0 to 0 means it should, the new state should be 0 or it should hold its previous state. This is previous state, this is new state. So you need, you are concentrating one, this is your output. So your output should be 0, or you can say it should hold its previous state. Both this case you will get here 0. Only this situation you see. Because your previous state is 0. So if it holds its previous state, then also you will get 0. And if it directly gives 0, then also it is 0. So my 0 can come from here or here. If it is 0 directly, or if it's hold its previous state. So from here you can say J should be 0, K can be anything. T from 0 to 0, it is holding its state, so T should be 0. If T is 0, then it is holding its state. T you can directly write for each cases. From 0 to 1, it should toggle, so it is T 1. 1 to 0, it should 1. For 1 1, it should hold its state. So T is okay. Now for 0 to 1, 0 to 1, it can directly take 1 output, or it should change its state. So it should change its state or directly 1. So means any two of these. Because your output should be 1, so directly you can get 1, or it should change its state. So you see this one, J should be 1 and K should be. So by now you know already what is this will be cross. So this will be 1 0. It should 1, previously 1, now come into 0. So it should directly give 0 or should it toggle. 0 or toggle means this and this case. So here he said K should be 1 and this can be anything. So by now you know. So you can write this one also. So this should be 1 or it should hold its state. 1 or holding its state means this and this. So K should be 0 and this can be anything. Okay. Now if you see all this diagram, so your T input, T should be such that what are the inputs they are taking? You say J, K, Q and Q and bar. So this type of inputs are coming in T. Here also you can see J, K, and in CD option also. So in CD also you can see T is written in terms of JK and input Q and Q. So that is your target. You need to write T in terms of JK and Q. Okay. So you need to write. So that means this is your output function, and this one you have to write in terms of this, and this. So out of these 3. In terms of these 3, because depending on these 3, this is your T, not this. This is the new state, not this one. So because whenever you give clock pulses, it check this. What is the present state? After that it changes to this. Once it changes, then everything this also changes. Okay, so these 3 are my targets. So how do we write? You go to normal K-map. So your JK, so it should be JK, it should be 3 cross 3 JK and QN. So if you go to this one, so it is 0 0 0 1 1 1 1 0, then it is 0 and 1. Okay, so when t is 1, so these are the cases. This you can see 1 cross 0, so this is one case, and j k q n, so this one j k k n, this one. So 1 cross 0 means it can be 1 0 0 1 1 0, cross 1 1 means 0 1 1 or 1 1 1. So you say this one 1 0 0 or 1 1 0 or 0 1 1 0 1 1, where is 0 0 1 1 and 1 1 1. So these are the cases. So if you simplify this one, these two, so your function t, that is your output t I am writing, so it will be, you see this one, it will, what is j is here and then qn bar plus it is qn and then it is k qn. So this should be your t. Now you can check these options, which option is giving this one. If you see this one t, what is giving t? The first option, option A, t is, it is giving j into qn bar, j into qn bar plus this one k into qn and then whole bar. So is it equal to the, no, it is just opposite to this one. Just if you give, if this is not there, then it would have been a perfect one. J qn bar, if no bubble is there, j qn bar and then k qn. But this bar is giving extra, so that's why A is not answer. So if you check B now, it is j plus qn, it is or multiplied by k plus qn bar. So if you take product, it is jk, jqn bar and qnk and then qn bar will go. So now you check, this should be jqn bar is already there, kqn, one extra is there, jk. So is it redundant? Can you take it out? So you can redundant, you can Boolean algebra also, or you can say here what is jk. Jk is this one. So if one more, or if one, you can take this one also pair. If you take one more additional pair, it will be jk. But why don't we take this one? Because we don't take one, because we need k-map, we need only the minimized one. So that's why I remove this one. So you can say B will be the correct option. You can simplify it also. How you simplify it in using Boolean? You can write it this one also. Let us write some Boolean expression now here. So if you do this one, it will be jkqn and then jkqn bar and then jqn bar qnk. So you can take from these two qnk common or kqn, it will be j plus 1. From here you can take kqn bar, sorry, jqn bar, it will be k plus 1. So j plus 1, k plus 1, anything plus 1 will give you 1. So you got the answer. This is the simplified one. From Boolean expression also you can see this is same. So first you try, if it is B is not there, then you should go to C, then you go to D. If nothing is there, then you try to simplify each one. Either simplifying each one can give you this one. But you have to think with each option before giving it as a, before you neglecting that option. Okay, now if you come to question number 58, the state diagram of the logic exhibits the delay in the output as shown in the figure. Where X is the don't care condition and Q is the output, X is the don't care and Q is the output representing the states. The logic gate representing the state diagram is. So if you see this diagram, this is oblique gives also give you the idea. So it is 1 0 means your output should be equal to 1, that is it's given. If it is 1 0, so if you write suppose X and Y are the input and this is my Q suppose. So what is the first meaning? 1 0. If it is 1 0, then it is going to 1. 1 0, that is going to 1. If it is 0 cross, then also it will go on 1. 0 cross means 0 0, it will also be 1 and 0 1 it will also be 1. So you come here again, 0 cross 0 0 it will be 1, 1 0 it will also be 1, 0 1 it will be also 1. Come here, 1 1 it is 0, because if you 1 1 then it is coming 0, 1 1 it is 0. So which gate gives you this idea? 0 0 1, 0 1 1, 1 0 1, 1 1. So you see this one, because this is repeat of this one. This is nothing but NAND gate. It is the truth table of NAND gate, that is your option D. Two monoshots multivibrator, one positive based and one negative. You can see one positive based, one negative based. So bubble is nothing but negative based, connected as shown in the figure. They are connected as shown in the figure. The monoshots M1 and M2 when triggered produce pulses of T1 and T2 width respectively, where T1 is greater than T2. The steady state output of V0. So you need to draw the output waveform for Q2. So everywhere they started V2 with 1. So let us start also V2 with 1 initial state. So if I start with my V2, so this is my, suppose V2 is nothing but Q2, which is my V0. So let me mark this one as V1 and this is at suppose V2. So if my V0, this is V0, correct it, this is V0. So if you want to draw V0, it start from 1, okay. How long it will be 1? It will be 1 because you see the short. This short is for, this is for T2 width. So this will be on for T2 width. From here only you can eliminate some option. Option A is eliminated, option B is eliminated. So option C and D, out of these two, anything will be there. Because it will hold its state, because it is monoshot. We have already seen one question on monoshot. So it will hold its state, whatever state it is getting, one high state for T2 time. It will hold its state, high state for T1 time. That is the duration they have given. And T1 duration is greater than T2, okay. So after that what will happen? It will come to 0. So once it comes to 0, it will be 1, Q2 bar. So once this becomes 1, so you see, what is the case here? What is the voltage here? This capacitor voltage V2. Because it is a RC circuit, so it will charge it to a voltage of this. So after some time, it will be fully charged. Okay, so that means it will get the full voltage after some time. There is no discharge path, so it will always remain at this voltage. So this is always 1. So this side is always 1, you can see. So this is always 1, and now you are getting this one 1. After this becomes 0, so this is 1. So what is now state? Initially when it is 1, this is 0. So something multiplied by 0 is 1. So your V1 is 0. Until now it is 0. So when it becomes 1, because this side is already 1, this side you fix, this is 1. Because this capacitor is charged. So now, as of now, it was 0, so it was 0. But now it is becoming 1, Q2, because it is Q2 is 0, so Q2 bar is 1. So it is 1 into 1, so this is 1. Now V2 is rising. Because it is rising now, so it will be positively. So because it is positively S, this one, and this is negatively S, so Q1 will get now high. So this is your V1. So let me draw V2 now, which is nothing but Q1. So Q1 will get high, and it will be high for how much time? It will be high for T1 time, and T1 is greater than T2. So by now also you can now see which one of the options. Option C is the, which one? Oh, we need V2, okay. So it will be T on. So once it is T on, okay, it will so this will hold its state. V2 is hold its state for how much time? T1 time. So after T1 it will fall down. Once it falls down, because it is now negatively edged, this one, so because it is falling, this clock you can see now, because this is the clock V2, it is falling, so it will come to 1 now. So this will repeat again. This will be for T2 time. So if you see this one, so this duration is T1 time, this duration is T2. So you can see which option will be the correct option. C. Now if you come to 60, the figure shows a digital circuit constructed using negative edge triggered JK flip-flops, assuming that the starting state of this is 0 0 0. It will repeat after the number of cycles. After how many numbers of cycles? So we have, suppose this is J0, so let's draw one by one. J0, K0, then it is Q0, J1, K1, Q1, J2, K2, Q2. This is first clock pulse, suppose second. Let me write at least 3 4. Then I will see if we need more, then we will draw. So what is the initial state? Initial state is all are 0 0 0. So this is 0, this is 0, this is 0. Q2, Q1, 0. So this is this, all these are 0. Okay. So we need to repeat the same thing. When 0 0 0 comes, that is my answer. After how many shots it is coming. So now let us see what is J0, K0. So this is always 1. J0, K0 you can see. So you put it always 1. So no need to think this one. Actually I write from here what is the, before giving first shot I think what is the input. So this should be always 1. So no need to write this one. Next K1 is always also 1. So K1 you write with this one. Similarly your K2 is always 1. So this area is always fixed. So you cannot change it here. Okay. Now what is, let us write J1. J1 is Q2 bar. J1 this is Q2 bar, you have to think this, and J2 is Q1, so this is Q1, so you think in this way. Okay. Now before starting this, before giving first clock pulse, let this input is fixed. Let us calculate this one. What will be this input? This is Q2 bar, Q2 is 0, so this is 1. And what is it? This is Q1, Q1 is 0, so this is 0. So now if you give clock pulse, it is 1 1, so it will change its state from 0 to 1. It is 1 1, so it will change its state from 0 to 1. It is 0 1, so it will remain 0. Next again, if you come here, it is Q2 bar, so Q2 is 0, so this is 1. And here this is J2, this is Q1, so this is 1. So now you give second clock, because this is 1 1, so it will become 0. Because this is 1 1, this will become 0. So this is 0. Now before giving again state, this state again you come, this is Q2 bar, this is 0. And this input is Q1, so this is 0. Okay. Now you give clock pulse 1 1, it will give 0, 0 1, it will give 0, 0 1, it will give 0. Now you come to fourth state again. What will be this one? J1 is Q2 bar, so this is 1. And J2 is nothing but Q1, so this is 0. So if you now give clock pulse now, it will be 1 1 0, it will be 1 1 1, it will be 0 1 0. Now again you check, this is fifth now, sixth now, okay, fifth. So before fifth, it is J1 is Q2 bar, so this is 1. J2 is Q1, this is 1. Now you apply 1 1 0 1, 1 1 0, 1 1 1. It will change its state. Okay. Now you come to that one, this is already 1. K1 is also 1. K2 was also 1. So now before giving again I will check this one. This is Q2 bar, so this is 0. And this is 0. So if we apply now, so 1 1 will make it 0. 0 1 will make it 0. 0 1 will make it 0. Now you see this is repeating. So after how many clock pulse it is repeating? It is repeating after 6 clock pulse. So 6 is the answer. If you like the video, then press the like button and please give your valuable comments in the comment section.